How do you find the domain of a composite function? Given two functions f of x and g of x. The domain of the composition will give you the value of x, where g of x is defined, and the g of x must lie in the domain of f. These are the rules you must remember. Let's take an example where we have a radical function and a linear function. Say f of x is root x, and our g of x is equal x minus 4. Now find the domain of this composite. Now domain of f of g. Solution. First, we must get the composition of the function. So our f of g, it's equal, since our f is root x, so we are going to replace the value of g of x in f, meaning anywhere we see x in f, we'll replace it with g of x. So this is what it means in a sense. So let's write it out completely now. We are going to have root x minus 4. This is the composite, but we are focused on the domain. Please watch out our other video on composite function, where we explain in details how to determine composite functions. Now, what are the restrictions that apply here? That is the first step. One of those restrictions, since we are having a root, is that you cannot take the root of a negative value, meaning that the radicand, which is our x minus 4, it cannot be negative. It can be negative. Okay, that is one of the rules. All right, and what is the second rule here? We can see that our for the radicand not to be negative, we cannot, x cannot be anything less than 4. If we put 3 here, for instance, we say 3 minus 4, definitely is going to give us minus 1. So s must be values from 4 and above, right? So x must be, which is the second restriction, x must be equal or greater than or equal 4. Okay, there are no other restrictions. Now we combine all the restrictions to write the domain. So it means that our domain, writing in set notation, will give us that our x is a set of all real numbers where our x is greater than or equal 4. All right, if you want, you can as well write it in interval notation if you so choose, unless otherwise specified. Now in interval notation, since we say that all real numbers, remember all real numbers begin from negative infinity to positive infinity, right? So we are going to have all real numbers starting from 4, including 4. Since 4 is included, I'm going to use a square bracket, right? 4 to infinity. And that is all for this. Let's take another example. In the next example, we have that our f of x is root x, and our g of x is equal 1 all over x minus 2 and you are asked to find the domain. Okay, solution. So we have that the first step is to find the composition of the functions, which is f of g, will give us our f replacing x with f of g of x in f. So our f is root x, right, which is root x, but instead of writing x, we'll replace it with g of x. You remember that? So we have x minus 2, which is the value of g of x. What is the composition? First, remember, we write the restrictions. What are those restrictions? The restriction is that we cannot have take the root of a negative value, meaning the entire radicand, which is 1 all over x minus 2, cannot be negative. It cannot be negative. What is the other restriction that applies? We know that we cannot, since we are having a rational function, we cannot divide by 0, meaning that x minus 2, right, cannot be 0. Okay, and for this to happen, we know that if we replace x here with another value other than value greater than 2, we will have 0. For instance, if we replace 2 with x, we are going to have 2 minus 2, which will definitely give us 0. So x must be any number greater than 2. All right, so x must be greater than 2. Now, if we have all of these restrictions, we are going to combine them to write in the domain. Now, how do we write the domain? Now, the domain will give us, remember, I'll be writing both in set notation and interval notation. So what this means from the restrictions, that x is a set of all real numbers, and we can write that this way: x is a set of all real numbers, all right, but x must be greater than 2, right? X must be greater than 2. Now this is in set notation. Like I said earlier, you can write it in either of the notations, set or interval notation, unless otherwise specified. Now, if we want to write it in interval notation, we know that 2 is not included, right? So we are going to use the parenthesis, which is a set of all real numbers starting from 2. Remember, 2 is not included. That's why we are using parentheses. If 2 is included, we are going to be using the square bracket. So between 2 and infinity. And this gives us the value for domain of the composite function. Alternatively, you can also write this, since 2 is not included, so starting from 3 to infinity. So this is, either ways, it is still correct.